Hello and welcome back to my channel. In this video I want to explain the change of state of ice at a negative temperature to 100 degrees centigrade, right? So I have a diagram I want to use. So let's say I have this diagram. So I have this here is 0. I'll explain everything in a bit, so just follow. I have what temperature? Okay, any negative, let's say minus 20 degrees centigrade. And then let's have another point here. So let's see, we have this, and then let's see, we have this. Okay, don't mind my free hand sketching, right? So here we'll be having 100 degrees centigrade, and at this point we call it boiling point. At this point we call it melting point. Okay, so let's see now what takes place between point A and point B, right? Between point A and point B. At point A to point B, you apply heat, right? And that heat will change this ice at minus 20 degrees centigrade to 0 degrees centigrade. So this is 0 degrees centigrade, right? So the heat that you applied here is called MC change in theta. So when you apply heat, this ice now from minus 20 degrees centigrade will change to ice again at 0 degrees centigrade. But this point, what takes place here is a melting of ice, right? So now from this point to this point, let's call it point C. What takes place here is melting process. At this melting process, this point here, temperature remains at 0 degrees centigrade. It doesn't change, right? Now the heat that is experienced in that portion is called what? MLF. That is latent heat of fusion. Now there is a rise again in temperature from point C to point D, and the heat that can raise this temperature from 0 degrees centigrade to 100 degrees centigrade is another NC change in theta, specific capacity, right? So it heats the water from 0 degrees centigrade to 100 degrees centigrade. Now at this point D to E, right, there is another heat that will heat the water, but it will still remain at 100 degrees centigrade. It will not change. The temperature will not change. That heat is called LMV, pardon me, MLV, right? Now this LMV is latent heat of vaporization. It can is the heat that takes place in this process, boiling process, right? So at this point the water vaporizes. Is that okay? Now if you look at this table properly, from minus 20 degrees centigrade to 0 degrees centigrade, we apply this heat, right? So if we want to calculate the total heat energy here, we'll be having this first. So this temperature is from minus 20 degrees centigrade to 0 degrees centigrade, right? Then plus the latent heat of fusion, where temperature doesn't change but remains at 0 degrees centigrade, we have MLF. right? This one is at 0 degrees centigrade. Then the heat that will raise water temperature from here to this portion is another mc change in theta. So this one will raise it from 0 degrees centigrade to 100 degrees centigrade, right? Then the last but not the least is latent heat of vaporization. Here it remains at 100 degrees centigrade. The temperature doesn't change. So you can see the progression from minus 20 degrees centigrade to 0 degrees centigrade for this. Then from 0 degrees centigrade and at 0 degrees centigrade, we had specific latent heat of fusion. Then we still have another specific capacity that will change the temperature from 0 degrees centigrade to 100 degrees centigrade. And at the boiling point, you have this, which is specific latent heat of what? Vaporization. Okay, if this is understood, I will take my time now to explain each of the parameter. Now, this is the mass of the ice, all this one, mass. Then this C now is specific heat capacity of the substance, right? Then this LF is the latent heat, right? Is the latent heat of fusion. Why this one is another specific capacity, why this one is the latent heat of vaporization. So if this is put in place, let's explain what this does. So this is heat change when the water changes from ice block at a negative temperature to the same ice at 0 degrees centigrade or reverse, right? Now, this is heat change when the water, that's ice now, changes from the solid ice to liquid water at the same temperature of 0 degrees centigrade. That is melting. So melting process takes place there. This is heat change when the water changes from water at 0 degrees centigrade to its boiling point at 100 degrees centigrade or the reverse. The last but not the least is this. So it is the heat change when the water, that's liquid now, changes from the liquid water to gaseous water, that's vapor now, at the same temperature of 100 degrees centigrade, that is boiling, right? So boiling process takes place here. So any question that is set now, if this is applied, we will then be able to do what? To find the heat, the amount of heat that is required to change any mass of ice at 0 degrees centigrade to steam at 100 degrees centigrade, or at minus 20 degrees centigrade to steam at 100 degrees centigrade. So if it is at 0 degrees centigrade to 100 degrees centigrade, we use from this portion, right? If it is from minus 20 degrees centigrade, we use the whole of the portion, right? Are we good? All right, so I'll see us in the next video where we will solve more problems using the understanding we've gotten here. Bye for now.